called that because it's written in Python. But based off their source, I've done a lot of reworking of it to make it better for our ECU and what we actually need. So in terms of display, it's an 8-inch display. It is sunlight readable. It is a 720p display, touchscreen, water protected, and so yeah, that's the display. So it's nice and bright. So I'll talk a little bit more about gauges later, but I guess another spec of it is that there is a 9 degree of freedom inertial measurement unit in it for attitude, basically. Attitude heading reference system built into it. So kind of like the more expensive MGL EFIS. And it also has a built-in barometer for your altimeter. And so this EFIS talks to the Max ECU over the CAN bus, so pretty much just 2 wires, and we can pull over 90 different data values from the Max ECU. So I just go over a little bit of the gauges that I've set up so far. We have an artificial horizon, your attitude, so you know your roll, pitch, yaw, your heading, altimeter. You can set the altimeter, the barometer setting, to get your altimeter correct. Vertical speed, indicated airspeed that's from a little board that I designed that actually feeds into the ECU, and then feeds to the gauges, or the EFIS. Your engine rotor RPM, battery voltage, all of your temperatures, air-fuel ratio, and your instantaneous fuel consumption. So pretty much everything you would need. I guess I'll talk a bit about, I'm going to give a little demo of just the first 2 layouts that I've set up. Talk a bit more about that later, but this is your primary flight display. Gauges are grayed out right now because this is just a screenshot when I was not feeding data in. Normally it will be green, yellow, red, and the values will be colored. But and also this layout is not finished yet, but this is just a sample, a representation of what you could expect from this. So pretty much all your most important engine parameters on the right. You got indicated airspeed, your heading, bank indicator, virtual horizon, altimeter, and yes, that'd be your primary flight display. Also have a vertical speed indicator. In the final one, I will have it so you can change your. I'm probably actually going to make this a little bit bigger because I know that some of you guys may not be able to see so well from a distance. So,
it's the vibration.
Right, it's the vibration. Okay. Yeah. So I'll make that a bit bigger, but on this one I have it showing the actual numeric values for the RPM. I know it's probably a lot more handy to see the percentage, to see 100% on both. So that's something I'll be working on, and units and stuff. I don't know if everyone's okay with Fahrenheit, but you'll have Celsius and stuff too. So I guess let's talk. So this is the pretty much your engine display. There might be some more or some less values here, depending on I guess what you guys tell me and come see me later. But you're going to have your EGTs, your cylinder head temps, your gearbox temps, and 2 nice big RPM displays. On the right, you're going to have battery voltage, coolant, fuel pressure, fuel flow, and your AFR. So, I mean, pretty much everything you would need to check on the health of your engine while you're in flight. And additionally, I put your primary what do I call it? Airspeed and altimeter in the bottom right, just so you can see that on both pages. So I'm going to talk a bit about the customization. So those were just 2 representative kind of sample layouts that I'm working on, but there's going to be quite a few more I'm going to do that will have more or less in different layouts, just depending on what you guys find to be the most important or what you're able to read. So pretty much I will have some documentation with it. So with those layouts that I provide on the device, it's not hard to enable and disable those pages. And I'm going to have documentation on that so you guys will know how to do it, and it'll probably be set, if it's like a factory build, it'll probably be set here. But in terms of, I don't know how many of you like to go into the MGL gauges and make new layouts for that, but that's not super straightforward even for the MGLs. For this, in terms of like changing what the gauge value is, so like say you don't want AFR, say you want ignition angle, that's something that I will document and will be easy to change. But in terms of designing new pages and layouts, I'm not going to recommend that for people because you need to know how to work around Linux, and it's easy to mess up, and I don't want you guys breaking your ethuses because I mean I could fix it so you're not breaking anything, but you know, don't do that. So in terms of who is this aimed towards? So first of all, XT290s. So it's not going to work on the XT-Ts because there's no CAN. It's not going to work on the or on the XE. So basically, the 290 Max ECU needs the CAN bus, which is this digital protocol that we take all the data over. So yeah, it's going to have more functionality than your standard 3-pack gauge cluster from MGL, but it does not have as much functionality as the full like 4 grand MGL ecosystem. So no radio controls, no maps, no ADSB functionality, and part of that is because as years go by, radios change, things change, how they get controlled changes, and in order to have to keep this being a viable product for, or viable ethos for you guys, it's best that not be built into it, because then it needs to be, code needs to change or something breaks. So it's a lot of added complexity. So if you want radio, you're going to have a head unit. If you want your maps, you could have an iPad mounted above, and you can run ForeFlight or whatever else, whatever other sort of flight planning you use. And in terms of price, don't have a final number yet, but it's comparably priced to the 3-gauge MGL setup. So it's it's not going to be $4,000 for like a Ethos Explorer from MGL is. And yeah, so that was just a quick little spiel about it. If you guys do have any questions, you guys can find me after this. I'll be glad to show you a little my little demo. A demo is in there. Didn't want to bring it out because it's raining. I don't have it. Still working on the case for the computer, so I didn't want to bring it out. That's still a work in progress, is getting all the mounting figured out. And we've had it in a bird, and we tested it, and it does work. So it is pretty far along in the development process, but it's just figuring out the mechanical mounting of it, and then do some more testing, and then we'll start getting it into production. So I would say like a month or two, most likely. So yeah, after our presentations, if you guys have questions about it, if you think maybe there's something you wanted to see on the layout that I didn't have, or if you have some sort of idea of what I could improve on or change, this is a work in progress, but if there's something you really, really want to see, come and find me in there, and we can talk about it. So, thank you guys.
Hey guys, I'm the other Allborn. I'm going to be talking to you about the development of the CXF 520 engine. So, I guess some of you may be asking, why do we want to develop a new engine? So first, kind of compared to the 202, the MZ202 is really a 20th century engine. It's air-cooled, carbureted, kind of old tech. And then we've also seen heat issues and a fairly low time before overhaul on those engines. Carb tuning, which is kind of a requirement for running a 202. Not everyone has mastered that art, and it's kind of unfair to expect someone to tune their carb perfectly. Plus, you can tune it perfectly on the ground and have it be bad in the air, or try to tune on the ground for your conditions in the air. It's just tough. And then compared to the 290 and the XCT, these are kind of our hot rod models, right? The engines are in lower supply for these, so a turbine, that's a very bespoke turbine that we're using. And then on the 290, we're kind of beholden to dealerships to send us those engines. And then there's kind of a constant, desire here to bring our components in-house, whether that be blades or really anything. So if we are able to make our own engine, there's no minimum order that we have to have. We kind of control our supply and our output. And we're also able to rapidly respond to changes in customer needs and customer desires. So what are the requirements for this new engine? So the power and torque needs to be at least as good as the 202. That's a given. We don't want this to be competing with our 290, so we don't want to be more powerful than that engine. It needs to be capable of running on 91 pump gas and have a lower fuel burn rate than the 290. It is a smaller engine, so that should be expected. The weight is not to exceed the full powertrain weight of the 202. Considering that that's a liquid-cooled engine, or that ours is a liquid-cooled engine, that's going to be an interesting thing to address. And then as far as electrical capacity goes, we want to have 200 to 250 watts of output by the stator at 12 volts, so around 16 to 20 amps. So now I'm going to go into the kind of choices that we've made in our design for the engine. So first of all, it's going to be liquid-cooled. We went this way because we get better control of our engine temperatures. We can reduce our oil mix kind of requirement in the engine, and you get a much cleaner combustion, so you're going to be decoking less often. And we're going to be going with a electric water pump, which we can pulse width modulate control through the ECU. This is really cool because we can operate it independently of the engine RPM. So it moves as much fluid as is required by the engine's heat, instead of kind of relying on you spinning your engine fast enough to move fluid. It's also easy to package. We can package it over by our radiator and make things easier. It's going to be a fuel-injected engine. We want this because we're going to get cleaner combustion. There's going to be a lot of tuning abilities, whether that's in-house or from our customers. And engine control can be done with the same ECU that's done on our 290. There is a less expensive version of that ECU with fewer features that would be appropriate for this engine. There are also other similar ECUs. And we're kind of still deciding whether we want to do a large single throttle or small dual throttles. Since it's not like a carburetor where you're relying on that opening to also draw your fuel in, and you get a bit more variability and controllability with that. It's going to be electric start. Initially, when we were thinking of this engine, we kind of bounced around the idea of it being some kind of manual start, but for the sake of being able to start it when we're in the air, if you want to, we're going to go for electric start. It's similar to some older Sea-Doo and Ski-Doo starter applications. You have a Bendix type starter mounted on the side of the case, and then a ring gear heated and shrunk onto the flywheel. And that should minimize the additional rotating mass, just because it's going to be a much smaller ring gear than we have on our other engines. Our cylinders are, it's a unit cast 72mm bore cylinder. The leads are going to be cylinder mounted, and the kind of interesting thing here is that our coolant flow is only from our cylinder heads through the cylinders and back to the head, so the block never becomes part of the equation. So there's never really any concern about coolant making it into your internals. The block itself is a two-piece design. We kind of designed it around either casting or machining, and currently we're leaning towards castings. We have a casting house ready to do some castings. I'm just waiting on some parts to arrive for a final fitment check before we have those done. How it's assembled, it's pretty conventional. You have studs that are threaded into the lower case. They go through the top case, through the cylinders, and then the cylinders actually bolt them down. One kind of thing that improves upon the 202 a lot is that we have these blow-through ports on our main bearings. What this means is we have forced lubrication of our engine main bearings. So on the 202, they were kind of relying on those bearings to just see a little sprinkle of fuel oil mix while they're operating. this forces that mixture through them. We also have main bearings retained by steel rings, so there's going to be a lot less fear of the crank trying to walk in the engine case. And our oil seals are going to be captured on either end of the block, so there's no opportunity for them to kind of run out. They will be serviceable though, just by removal of end plates, so it's not like you have to split the block to take them out. The crankshaft that we decided on is a pretty typical multi-rev press-together design. This is done throughout the power sports industry, and it applies to us pretty well. The center labyrinth seal, which seals the two crankcases from each other, is going to be made of aluminum, so they don't really wear as long as there's no foreign debris inside the engine, which should never happen. So it's fully rebuildable by any power sports kind of engine builder that knows how these things work. Not really a DIY project, but it is a rebuildable piece. And then our flywheel speed, so our timing is always consistent from engine to engine. Here are just a few renders of the engine right now. So these are kind of dummy representations of the cylinders. I was waiting on those to actually come in, I guess, before modeling them fully. But you see our blocks, our end plate, stator's under here, stator mount, starter, ring gear, all that great stuff. So I think that about sums it up.
One small note about that is the ECU that is going to run this engine is the max ECU, the same ones on the 290. So if you were to use the same grade of max ECU, then the EPIS panel you were viewing before will also work on this application. So we're trying to dovetail everything together and get some coordination between them all. So other than that, I think that's it, guys. Food is coming if you want to stay for supper. 6-ish, 7-ish, somewhere in that area.
Pick it up at 6.
Pick it up at 6, so probably about 7 o'clock, 6:30, 7 o'clock we'll be eating. So everybody's welcome to stay, be barbecue. And other than that, have fun in the rain. Tomorrow's supposed to be a fantastic day, that's all I hope it is.